is verifying trig identities. An identity is, in math, is going to be two things that are equal to each other. For example, long ago in, at least by third grade anyway, I know that you were doing these because my son is doing these now, but you would do things like, they would teach you the property that was your additive identity. Your additive identity was adding 0 to anything because it still equals itself whenever you add 0. What's your multiplicative identity? Times 1, right? If you multiply something by 1, it gives you itself. So whenever we're talking about identities in math, we are talking about things that are equal to each other. So you've done something to one side or done something, but it still remains the same. So these are going to be a little more complicated than your third grade additive and multiplicative identities. But trig identities here, the idea is we are proving or verifying that the two sides of an equation are actually equal to each other. So, so go ahead and write this down because this is, these two things right here are going to be important. So when verifying trig identities, you must simplify in order to show that both sides of the equal sign are the same. And this is really important here. You may not move anything from one side to the other. So this is not like solving an equation where we subtract 2x and subtract 2x from both sides. I can't tell you how important that last part is. You cannot move anything from one side to the other. Because with equations, we typically do, but we cannot here. Okay, so let's do an example. Here's our first example. We've got sine cubed x plus sine x times cosine squared x equals sine of x. A lot of sines and cosines and x's. Told you it's time to separate the men from the boys. So for this, what I do whenever I do these problems is I go ahead, I draw myself a line down the middle of that equal sign. Sometimes, like if you've had me for the lower level classes, I'll do that with my other students as well because they put their equal sign all over the place like crazy people. But I'm going to draw this, and I cannot move anything from one side to the other. So I'm either working on the left-hand side or I'm working on the right-hand side. Now, in this particular case, is there anything we can really do to the right-hand side? Not really. So, obviously, on this problem, we need to do our work on the left-hand side. So, just looking at it, anybody see anything you think you could do? We can't change everything to sine and cosine because they're already sine and cosine. What? Well, I can't really multiply anything because it's like this is multiplied together, but like I can't change it, right? Because I can't change a sine and a cosine multiplied together. I think I might have heard the word. I could factor. What could I factor here? I could factor those. So I've got 3 sines here, and I've got 1 sine here in the second term, right? So I could factor out a sine. And so I would write sine x out front. And then just like a greatest common factor, like if you're pulling an x out. So I had 3 sines. I took one of them out. So now I'm just left with 2 sines. So sine squared x. Plus, right here, I had 1 sine. I took it out. So I'm only left with the cosine squared. Oh. This is what I feel like with these problems, you have like a moment of epiphany where things become clear. Sometimes they happen really early on, like this problem. Hopefully you're having that moment here. Sometimes it takes a long time, or possibly you never get there. But, so, right now, if you have had an epiphany, what is it? This stuff right here, sine squared x plus cosine squared x equals 1. So, I need you to write that. Because the good thing about these problems versus what you were doing last night is you already know the answer is sine x. You need both sides to equal sine x. So, you know the answer. So, at the end, you need to have sine x, but you need to show every step that you do to get there. So, you need to show me how you replace this with 1. And then, obviously, sine of x times 1 is sine of x. Work down on these problems, please. And then, so, the whole point of this is to show that both sides of the equal sign are the same. So both of these equal sine x right now, so you know that this is an identity that has been verified. And I will, unless I've made a mistake and the problem's wrong, I will only give you ones that are correct, that do equal each other. Yes, that's one of your Pythagorean identities. Remember, guys, that you'll have that quiz on Monday, which I forgot to post to Canvas, but I will post that quiz to Canvas today. I'll post the key for you. So on Monday you'll have that quiz where you got to have all of those identities memorized. So like as we do more of these, like every time you see sine squared x plus cosine squared x, you should think, oh, that's 1, and just replace it with 1 for those. So the more we do these, hopefully the more they'll sort of pop out at you. There. Okay, questions? Okay, so this next slide you don't necessarily have to write down. I'll post these to Canvas so that you can see them if you need to look back at them, and I don't want to spend the whole class period writing things down. So some strategies that you might want to try for this. Generally, I tell students to work with the most complicated side first. On that last problem, we didn't have a choice. You couldn't do anything to the other side. Substitute basic trig identities. That's pretty much like your Pythagorean identities or reciprocal identities, those things that you would have. Sometimes it helps to factor, like we saw in this last problem. Sometimes you don't need to factor. You need to do the opposite. You need to multiply them together, like we saw in that problem that we did when we were checking the homework. Sometimes if you have fractions, you might need to get like denominators and add those together. A good strategy also is to change everything to sine and cosine. As I was telling you guys yesterday, you kind of have to do a trial and error here. Try this, see if it works. If it doesn't, try something else. Because I can't tell you, here's step 1, step 2, step 3, step 4. You have to sort of have like a bunch of strategies that you've used and you've seen this problem. Oh, this looks a little like it. Maybe we should try to factor here. So those are the sort of things that we'll do. If you didn't get all those copied down, they'll be posted to Canvas if you want to look at those. So here's our next problem. So we've got, for example 2, we've got cotangent of theta equals cosecant of theta over secant of theta. All right, you can work on both sides, or you could just work on one side. It does not matter for this time. If we're going with that strategy to work with the most complicated side first, then we would probably pick the right-hand side here. So, ideas. What do you guys think we should do? One over sine and one over cosine. So we could change everything to sine and cosine. We could use those reciprocal identities here. So cosecant of theta, Trevin, what is cosecant of theta? 1 over is sine, because you have to have a co in every pair. So cosecant has to go with sine. It can't go with cosine because you have two cos. And then secant, Spencer, what is secant? 1 over cosine theta. And I like to put some parentheses so I don't get things all jumbled up with that complex fraction. So here we do not like to have complex fractions. How do we get rid of complex fractions, Richard? It's easy as pie. Yes. So dividing fractions easy as pie. We're going to flip the second and multiply. So we'll have 1 over sine of theta times cosine of theta over 1. Is anybody seeing beautiful things happen here? So if you multiply that together, you get cosine theta over sine theta. And it is not tangent, but it is cotangent, which is what we wanted in the first place, right? That's what we have on the other side. So we know that we've verified this identity. So you could make it 1 over tangent x if you wanted to, but then you would also need this side to be 1 over tangent x. So like whenever you change this to cotangent, you would have to make it 1 over tangent. It does not really matter what you get as long as the two sides equal and everything you have done is logic. So, like, we will have a quiz on this probably Wednesday next week. I don't want to give it on Tuesday because I won't be here Monday, so I want to have some time to correct any problems you may have had then. So we'll probably have a quiz on this Wednesday, and for this quiz, it's going to be on paper, and I am not, like, I'm checking your work, not necessarily your answer, because you should know that the two sides of these are going to equal. So if you don't know how to do it, at least make sure at the end you get cotangent and cotangent, right? Even if you, like, fake something, you had, like, if you just said 1 over sine theta times cosine theta over 1, I don't know what to do. Cotangent theta equals cotangent theta. I mean, at least fake it at the end, even if you don't know how to do it, because maybe I might assume, or maybe you were so close that you might get some points there. You might not get any points for it, depending on where your logic is at, but always make sure at the end you get the same thing on both sides. Another thing you could have done here instead, if you, we could have stopped right here on this side, because cotangent of theta, we know it is cosine theta over sine theta. So I could have worked a little bit on both sides. I could have said this side, we got cosine theta over sine theta. Right here, we got cosine theta over sine theta. They match, so we could stop there. So it just depends. Like, you can work on both sides. On the first problem, we didn't really have that option because one side was just sine. But over here, we could work on both sides if we want, or just one side. Okay, questions? All right, let's try another one. Here's our next one. All right, so we got secant squared theta minus tangent theta cotangent theta equals tangent squared theta. So probably probably left side is the best place for us to start. We've got more stuff going on the left-hand side. Any ideas of what you might want to do? If I see secants and tangents and cotangents, I don't like them. So it's not always the best move, but it is always a possible move just to change everything to sines and cosines so that you don't have that tangent and cotangent and all of that stuff. So secant squared theta. Lapita, what is secant of theta? What can we replace it with? 1 over cosine, and it'll be squared since, I didn't mean to do that. What have I done? Okay, there we go. I've switched colors too. Good gracious. Okay. 1 over, oh, come on. There we go. 1 over cosine squared theta minus, let's see, Adam, what tangent? Sine over cosine. And Boone, what's cotangent? It can be 1 over tangent, but since I went with sine over cosine here, let's do cosine over sine. That would work also, though, if you did not change tangent. So what's going to happen here whenever I have sine over cosine times cosine over sine? Everything cancels, right? The sines cancel and the cosine cancels. What do I get when everything cancels? I get 1, not 0. It's not gone, because if you have something divided by itself, if you have sine times cosine over cosine times sine, something over itself equals 1. So you're going to have 1 over cosine squared theta minus 1. Okay, questions right here. Okay, because I want you to be able to follow what we're doing here. Not necessarily be able to see what you were supposed to do at first, but to follow what we're doing. Yes. 1 over sine is cosecant. Yeah, cosecant. All right, ideas. Okay, so this is secant squared. We could change it back. I'm going to show you another way to do it because some students would not have done it that way. But this is a little bit quicker. All right, I could change it back to secant squared. That kind of seems like a Pythagorean identity to me. If you look at those Pythagorean identities that you may or may not have memorized yet, let's put this over here on the side. What was the Pythagorean identity that had secant in it? Tangent squared theta plus 1 equals secant squared theta. So that's not this identity, but there's a few ways I could do this. Well, probably there's a lot of ways you can do a lot of these problems. What idea do you have, Alex? What do you think from there? Okay, so if we move this 1 over right here, like this, tangent squared theta equals secant squared theta minus 1. Kind of like we did with that 1 minus sine squared theta, or the 1 minus cosine squared theta. So this stuff right here equals tangent squared theta, which is what we had on the other side, so we know we did this right. Okay, so that would work. Another thing you could have done there, I'm going to show you a few different options because there is not just one way to do a lot of these problems. That's another thing that students have trouble with sometimes. Like, let's say that we had not done what Alex did there. Let's say we just had this. So secant squared equals tangent squared plus 1, right? So we could have said secant squared is tangent squared plus 1. So we could have replaced this with tangent squared plus 1 minus 1, right? And then the plus 1 and minus 1 cancel each other out, and we get tangent squared. So that was theta right there, of theta, which would work also. So we could do that instead. Let's say most all students do a pretty good job of knowing sine squared theta plus cosine squared theta equals 1. Most students get that pretty well. Most students can at least cope with some sines and cosines. But some students can't remember that at all and really hate secants and tangents, cotangents, and all of that. So let's say that you are one of those students and you never think of secants and tangents and cotangents and all of that. Let's go back to this point right here. So we go back to this point. There's another way we could have done it from here without using secant. I could have put this over 1. And I could get common denominators. So if I want to get common denominators, what would I use for my common denominator here? It would be cosine squared theta, right? So that would mean I would have to multiply this by cosine squared theta on top and bottom, which would give me 1 minus cosine squared theta over cosine squared theta. Okay, what does 1 minus cosine squared theta equal? That is sine squared theta over cosine squared theta. And what is sine over cosine? It is tangent, so that equals tangent squared theta. So there's another way that you could do it. So whenever I'm going on Monday, I'm going to leave some of these problems for you to do, and I'm going to give you instructions, like I want you to work on it for a little while by yourself, and then everybody's going to you'll have all of them put up on the board around the room. But Jacqueline might do a problem one way, and Alex might do it another, but they might both be right. You can be wrong. You can do things that are incorrect. For example, you could do something, what I see happen the most, the worst problem I see with this is bad canceling. So what I see students do wrong a lot is like they see 1 minus cosine squared over cosine squared and they cancel that cosine squared. Okay? You cannot do that because it's 1 minus cosine squared. Those are separated by minus signs, so you can't cancel. Everything has to be multiplied for you to cancel. So that would be bad. Plus you'd get 1, and there's no way of turning tangent squared theta to 1, so it wouldn't give you the right answer. But you can get these wrong if you do something that's logically incorrect. This is not one of those situations where anything, as long as you feel like it's right, like English or something. But this is, you can have different answers. Okay, don't panic. Don't panic. Yeah. I will tell you, I think this one's easier than the last one. I think it's easier than the last one. But this type of problem can induce panic. It looks terrible. What would you do? It is not. No, it is not. It has to be sine squared plus cosine squared equals 1, and it has to be squared. So like sine plus cosine does not equal 1. It has to be squared. So it has to be added, and they have to have both of them squared. So it does not equal 1. All right, you got 2 options here. You can work on the left or the right. The left is a little uglier, but it is all sine and cosine. The right doesn't have sines and cosines in it. So, Richard, I'm going to let you pick which side. The right? Okay. So, to work on the right-hand side here, what would you try? Secant is 1 over cosine of x. And actually, is that alright with you guys? That's going to be, it's alright if I write it like this so it doesn't take up quite so much room. 7 over cosine x. Because you'll have 7 times 1 over cosine x. That is 7 over 1, so it'll be 7 over cosine x. I'm okay with you skipping like a step like that. You don't necessarily have to write it, but you can't just skip to the end and say this equals this with no work in between. All right, and then, so, Richard, for this part, what would you get? 5 over sine x. Good. Okay, believe it or not, we're actually really close to the answer here. So when you've got this, we want to add them together, but we can't add them together unless we have common denominators, right? So, Richard, what would we use for a common denominator? Good, cosine times sine. So that means that here we have to multiply by sine x and sine x. And over here we have to multiply by cosine x and cosine x. And so we've got 7 sine x plus 5 cosine x over sine x times cosine x. Look at the other side. They match, right? So you really didn't even simplify on this one. You've made it look worse. But it does not matter. You are proving that the two sides equal each other. So that is correct. Okay, I think that one's easier than the last one, even though it looks scarier than the last one. Okay, questions on that? Alright, I do want to show you how you could do it if you worked on the left-hand side instead. Okay, because it's not too bad either. Some might even think it's easier. So, I'm going to erase this. You might just want to do it like over to the side. I'm going to erase this so I can show you guys the other way that you could do it. So, let's say that we wanted to work on the left-hand side instead. This is not erase as easy as the Smartboard program. So, have I told you guys about the love connection? Have we done the love connection any? Okay, so when you have something in the denominator that is just a single term, you can divide the numerator by, or divide both terms in the numerator by that term. Okay, Miss White used to always call it the love connection because if you circle them like that, it kind of looks like a heart there. So I could write this as, this only works whenever you, well, it'll work anytime, but it's better whenever you don't have a plus or minus sign in the denominator. So 7 sine of x over sine x cosine x plus 5 cosine x over sine x cosine x. So you could use your love connection here. Please do not go to college until you're like super smart college professors that you did the love connection on this problem. They will laugh at you. That is actually not a mathematical term, believe it or not. So you're really just dividing the numerator by both terms of the numerator by the denominator. But love connection helps me remember what to do here. So whenever you do that, sine and sine will cancel here. Cosine and cosine will cancel here. It is okay to cancel because everything here is multiplied, and everything here is multiplied. The plus sign's in between two separate terms, so you can cancel. And so that gives you 7 over cosine x plus 5 over sine x. So you could go over here and change this, like do the first step that we did whenever we were working on the right-hand side and change it to 7 over cosine x plus 5 over sine x. Or you can just kind of move that cosine back up to the top and make it 7 secant x and make this 5 cosecant x, and then it matches the other side. So that's another option for the same problem. Okay, questions? All right. Wait, there we go. Here's our last one. This one, definitely going to have to work on the left-hand side. Right-hand side's just 1. Can't do much with that. So we've got sine A over cosecant A plus cosine A over secant A. And I do not like those cosecants and secants and stuff, so I'm going to change those. So I'll have sine A over 1 over sine A plus cosine A over 1 over cosine A. Okay, and then I've got those complex fractions, which I don't like to have, so dividing fractions is easy as pie. Flip the second and multiply. So right here I'll have sine A times sine A over 1 plus cosine A times cosine A over 1. And then so this is just sine squared of A plus cosine squared of A, and what does that equal? That is going to be 1, which is the other side. There's other ways to do it. You could have got common denominators or something here and messed with it that way, but this is probably quicker than trying to get common denominators here. Okay, questions? All right, so your assignment is took from page 434. And you guys are going to do 13 through 26. Let me make sure there are none there that I need to throw out. Let's not do number 22. It's really not that hard, but let's not do 22. Okay, so on Monday, the sub is going to give you the identities quiz first thing. Then I'm going to have her check your homework to see that you've got something for 13 through 26. So that means that you've copied the problem down and you've tried at least one step on each problem. Hopefully more than that, but at least one step on each problem. Okay, past copying it down. And So she's just going to check that it looks like you've got something. And then after she's done that, I'm going to have you guys put all the questions up on the board around the room. And I want everybody to sort of ask each other questions and make sure that you've got the right answer. Hopefully, between all of you, you'll be able to get a right answer for all of them. If there are any that you kind of work together and nobody's really got it, or you're not really sure if anybody's got it right, then just make a note of those, and we'll look at them on Tuesday whenever I'm back. And then after you finish doing that, there'll be another worksheet that I'm going to have you guys work on that'll also have more of these on it, and you can work together on those. Okay, so that'll be what you'll do on Monday. On Tuesday, I will be back, and we'll go over anything you guys have questions on. We might do a few extra problems for some practice. Wednesday, you'll have a quiz. Wednesday's quiz will be the real quiz. Monday's quiz is the one that you need to make 100 on because you just have to memorize it. In fact, I'm going to go put the answer key to Monday's quiz on Canvas right now. Just go memorize it. Okay. All right, so go ahead and get started on this. You've got a little bit, like 20 minutes or so, to